Hello. Okay, so this is Unit 2, Lesson 1, called Scaling Robots. So, as you can see, our warm up says create a robot face that you like by dragging the points to adjust the distances. So, I can take this antenna and I can move it up, I can move it down, I can then take my little thing here and move it up and down, in and out, so I can make my robot super short and skinny or fat or big or however I want to do that. And then I can actually move the eyeballs to make a different kind of robot. So I'm going to make my robot look like this. And I'm just going to take note of the height, width, eye distance, and antenna. And I'm actually going to make that a little bit bigger so I can see that. Okay? I'm going to press I'm done. So that's my robot. You make a robot. And then when you're done making a robot, we can move on to the next question. This says scale the robot. Here is your robot. Complete the table to create a new robot that is a scaled copy. Then press draw to check your work. So I had students in class today go through this and make a scaled copy until it tells them that they were correct. So for example, I can put, if this is 6 and this is 12, that's 2. I'm going to put 8 right here, and then I'm going to put 9, and then I'm going to put 7. So that is what I'm going to do. And I'm going to draw my robot. I'm going to see if those are scaled copies. Okay, they are not. So I have to kind of think through, what is a scaled copy then? Well, I know that if something is scaled, like to scale, I take pictures. So I know that when I have to print pictures, when I make a scale of it, it has to be proportional. So in class today, we actually wrote out definitions as a class. We came up with one and we wrote it in our notebooks of what a scaled copy was. That's something that you can talk to your friends that are in that class for. But most of the classes said that a scaled copy is a copy of the original figure that is proportional to that original figure. It can be bigger or smaller, but it has to stay proportional. So in this case, looking at these units, they are not proportional. I know that in order for something to be proportional, I have to multiply them or divide them by the same number. So in this case, I see 6 is being multiplied by 2 to get 12. So I'm going to multiply by 2 and see what I get here. So that's 6 and that's 2, and let's see what I find. Perfect. So there is my scaled copy. When you're done doing that, go ahead and move on. So now let's talk about scale factor. So scaled copies always have a scale factor. We know that a factor is a number that's being multiplied by another factor or another number. So let's look at Imani and An's work and show or describe where in their work we can see that the scale factor is 2. Looking here at Imani's work, I see that they're actually multiplying their original measurement by 2 to get 10. So our scale factor obviously is 2 right here. Same here. I do the same thing for all those factors. But when I look at An's work, it looks a little different. So I see down here, she's made fractions or ratios. I like to say that because when we think about proportions, we know that they're ratios and we know that they stay equal to the other ratio in some way or another. So we see here, we have a ratio 10 over 5 is equal to 6 over 3, which is equal to 4 over 2, and equal to 3 over 1.5. And if we simplify those, we see that actually that is all 2. So then we can see our scale factor is 2. We can see that. I didn't mean to do that, but there you go. So I can describe what I just said in my words, but I want you to describe it in your own words. So go ahead and finish that. You can just pause the video and then do your answer and go when you're ready, or however you want to do that. But we're going to move on. So number 4. Imani's robot. So Imani made another robot and tried to make a scaled copy. Taking a look here at these measurements, do you think the new robot will be a scaled copy? I told the kids in class today that they cannot pick not enough information, that they have to pick one of these two because you have enough information and you're totally smart enough to pick an answer. When we're looking at this, we see our original robot, this one right here, has 2, 6, 4, and 1. And then our new robot goes up some, and it looks like if I just do quick math in my head that they actually go up by 6 units. So I can add 6 units to 2, 6 units to 6, 6 to 4, 6 to 1, and I get these new measurements. But I want to say that based off of what we did in the last problem, I know that if it has to be proportional, I'm not going to add. I have to multiply. So would these be proportional? Would these be scaled copies? You tell me and then explain your reasoning. Okay? Now I want you to try it. Press draw to test your prediction. If needed, change the measurements so that the new robot is a scaled copy. So if I leave my measurements as they are and I press draw, we can now see if they're scaled copies. I can already tell they're not. Yeah. So I can see, okay, they're definitely not scaled copies. So I'm going to try again. And I'm going to use a scale factor of 2 and see what that does. So if I multiply by 2 here, that's 4. That's 12, that's 8, and that's 2. And let's see where we go from there. There we are. So there's our scale factor, or our scaled copy. Now you can use a scale factor bigger than 2, less than 2, but the point is that whatever your scale factor is, you do the same thing to all of these measurements. Next. Anushka's robot. So Anushka made the small robot, then she tried to make a scaled robot, or a scaled copy of the robot. So in class today we thought, and then we discussed with our pairs, but let's just take a look here and see what the difference is between this robot and this robot. I notice a way that she got from 3 to 9, and 4 to 16, and 1 to 1. I wonder if you notice the same thing. I'm going to let you think about it. So I know that she multiplied 3 by itself to get 9, and she did the same thing here. She multiplied 4 by itself to get 16, and 1 by itself to get 1. How would you help her make that a scaled copy? Right now, her scale factor isn't the same for all of the measurements, and if we want a scaled copy, then it has to be the same. So what would you do? I'm going to let you answer that and then go on when you are ready. Naila's robots, I don't know if I'm saying that quite correctly, but I hope I am. So she drew a small and a large robot. We have to help her make the large robot a scaled copy. So we can select the lengths up here and change them as we need to. I'm actually just going to change the width and the antenna. So I see that 5, if we're starting here at the small one, 5, the scale factor from 5 to 15 is going to be 3. So I know that I have to change my antenna to be 6. I have to change my width to be 16. Maybe. And so I'm going to then say that my scale is 3. I'm going to try it. What did I do wrong? Oh, wait, I see what I did wrong. This has to be 24. I did my math wrong. I was thinking 2. There we go. Now let's try it. Yep, there we go. Okay. Oopsies. Sometimes we make math mistakes. Okay, so I see that my scale factor is 3, and I moved up on each of those measurements by 3. Now, in class, we went a step further, and we discussed, well, what if we're going from the large triangle to the small triangle? So if my original point is 15, what would I multiply 15 by to get to 5? So I would have 15 times something equals 5. In class, we talked about how it's a fraction. It would be 1/3, and we could turn that to a decimal. But either way, Apollo, that's my sock. Don't chew on my sock. Hold on, I'm sorry. Those are my socks. How'd you get that? No, kennel up. Kennel. I said kennel. You listen. Thank you. No, kennel. Apollo, kennel. Stay. Don't. Ugh. Anyway, sorry. Okay, so we talked about how that would be 1/3 if we were starting with the bigger triangle and going to the smaller triangle. And that's something that you'll see on your homework, where you start with a bigger image and have to go to the smaller image, which then means that your scale factor has to be less than 1 for it to be that smaller number. So here's our synthesis. How can you use lengths to determine whether a figure is a scaled copy of another figure? So we start with our small one and we go to our big one. What am I multiplying 10 by to get to 15? A couple ways you can find it out. So you can either just multiply 10 by a bunch of different numbers to figure it out, or the opposite of multiplication is, of course, division. So you can then do what On did at the very beginning, which was divide your two numbers and find your, essentially your unit rate. So if I'm dividing, I know that 10 goes into 15 1.5 times, right? So now we have our scale factor of 1.5. So I can use division to help me find my scale and see if these are equal, but then I have to make sure that I do the same thing with all of these numbers. So I have to do the same thing with 9/6, which is equal to 1.5. And then I have to do the same thing with 8 and 12. So 12/8 and make sure that that's also 1.5. And it is. So I know that the scale factor is 1.5 and that these two shapes are in fact scaled copies of each other. And then I can explain that with words. Last one, show what you know. Figure B is a scaled copy of figure A. Determine and label the missing side lengths of figure B. So this is another example of what we have to do in order to find missing side lengths. We have to figure out the scale factor. I can do that either by using this right here, 2.5 to 7.5, and I can figure out what's the missing factor. I can divide them, but I see two numbers that are easy and they're nice numbers. So what do I have to multiply 5 by to get to 15? I know immediately that's 3. So my scale factor has to be 3. 5 times 3 is 15. 2.5 times 3 is 7.5. 1.5 times 3 is 6 times 3 is what? And you can then put your explanation here and also give me your answers there. Since you weren't here in class, you don't have to rate it, but I also would like to hear how you do hear how you would rate it, especially since you weren't in class. This lesson is obviously pretty difficult to do by yourself because you had mentioned that it was confusing. So you can tell me that here too, and then I can let people know so that maybe we can let it kind of fix it so it's not so confusing, I guess. So there you go. That's the end of that. I am going to actually exit out of here and go to the lesson practice. And I just want to give you a heads up on this. So starting here, this kind of gives you some information on what you might need if you're unsure about the scaled copy or scale factor or even what proportional might mean. So that's here. You can look back on that. This is the problem that a lot of people struggled with before we left school today. I am going to tell you, start out with this. What are your measurements? If you count each of these units, you'll see that that has 5 units. 1, 2, 3, 4. This has 4 units. You could do that for each side. You have 2, 4, 2, so on and so forth. But honestly, I just started with these ones because they were big, they were easy to see. I can see looking really closely that this is slightly more than 1, but I'm not exactly sure how much. But I know that this right here is 1. So I'm going to use that as my kind of determiner. In order to find this side length, I have to figure out what my scale factor is. So I know that if I have 4 and I'm needing to get to 1, 4 times something is 1. And if I divide, that's going to be 1/4. Okay, so I know that if I multiply 1/4 and 4, I will get 1. But I can also then change that into a decimal, because I don't know if you can. Oh, you can, I guess. You can put 1/4 in here. But you could also tell me the decimal. So it'll tell you the decimal as well. And you can then tell me how you know that that's your answer. So I know I kind of gave you the answer there, but I hope that that can kind of help you as you move on to the rest of the homework. If you have any other questions, please don't hesitate to reach out. Okay, we'll see you tomorrow. Bye.